Thank you very much. So I'm going to talk about something completely different now, leave behind biotechnology and talk about heavy industry. As you said, at Boston Metal, we are working to change, really revolutionize how steel is made. And by doing that, you can eliminate 10% of CO2. So though the innovation is very different, the end goals are very similar to what we heard about this morning. So the work that's happening in biotech, in healthcare, is working to ensure, eliminate diseases, improve the quality of life, extend life. We are doing the same, but at the climate scale and at the global scale, ensuring that the world that our children and our grandchildren inherit is one where they'll be happy to have a longer life and will have quality of life from the environment. They'll seek to extend their time on Earth. We are also leveraging innovation from other industries and showing how that can enable an industry like steel that's very, very old to see a complete change. We use clean power. If you look at what's happening in the electricity sector, it's about 150 years old. It's been based on carbon since the early days, but that's the end of the carbon age is in sight. All the new power that's coming online is dominated by clean power. And in the decades ahead, if we're going to hit our climate goals, the carbon age for electricity will end. You're seeing similar effects in transportation, where the internal combustion engine, another 150-year-old technology, is on its way out. States and countries already have goals to ban that in the next decade because you have electric power. We are tackling in steel not a 200-year-old technology, but a 3,000-year-old technology for making steel. The Iron Age was 1200 BC. We figured out that you mix carbon and iron ore together. It's a very efficient way to get steel but as a byproduct, you get CO2, about 2 tons of CO2 for every ton that's built. And when we start to talk about some massive scales, as I'll explain, the impact becomes immense. 10% of global CO2 just from iron and steel production. We are revolutionizing that by taking coal out of the equation, taking carbon out of the equation. That hasn't been done in 3,000 years, and replacing that with clean electricity. And the byproduct is that you can take emissions from 10%, if you're using clean power, and drive that down to 0. And that is an essential innovation because steel is essential everywhere in society. The building we're in today, the infrastructure all around us, renewable power. If you want to build a megawatt of wind power, you need over 100 tons of steel. And you look at the gigawatts of renewables that are being built. Transportation. If you look at the vehicle fueled by an internal combustion engine, the life cycle emissions from that car is dominated by the gasoline per mile. If you switch to an electric vehicle, powered by clean electricity, the life cycle emissions are dominated by steel and the manufacturing of that vehicle. So it's essential to ensure that the clean electric vehicle you're driving doesn't have dirty steel in it. That's what we're working to do. But it is an extremely carbon intensive industry and a very entrenched industry. 2 billion tons of steel were made last year. That's the Eiffel Tower, 250,000 times every year. And with that comes billion-ton levels of CO2, 8 to 10%. But we are developing a brand new equation for how you make steel. So if you look, I talked about the Iron Age, that's the basic formula on top. Mix iron ore, which is iron and oxygen bound together, mix that with carbon to get up the temperature. This is high temperature industry. I'll show you a video in a few slides, 1500, 1600 degrees Celsius. As you mix those two together, you get liquid iron that can go downstream into all the different grades and products of steel we use, but you get CO2. Again, about 2 tons of CO2 for every ton of steel that you produce. Our equation is on the bottom there. We call it molten oxide electrolysis. So using the electron, the power of the electron, to do what carbon has done for a few thousand years. No carbon in the equation. So you get the same high quality liquid iron, but you get oxygen as a byproduct. No scope 1 emissions. If you're using clean electricity, no scope 2 emissions. So you can truly drive it to 0 from where it's at today. I won't go through all the details here, but I'll talk a little bit about the core technology and show an animation and then show it operating in real life. So it's an electrolysis process. If you're familiar at all with batteries, you'll hear some similar terms. There's a cathode, there's an electrolyte, there's an anode. For us, the cathode is the product. As we run the video, you'll see the orange portion at the bottom of the cell get bigger over time. As you make metal, that's the cathode of the equation. There's an electrolyte, which is where the iron ore dissolves. The whole design of the electrolyte is that you want the least stable oxide to be iron oxide. So as you pass current, that breaks down. Everything else stays in the electrolyte. And then there's an anode technology, and that was the core of the innovation that came out of the university, MIT in Boston, or in Cambridge. About 10 years ago, Boston Metal was formed to take that innovation from the lab scale, making grams of metal, to where we're at today, making tons of metal, and ultimately to the millions and billion ton level. As you operate this process, it's continuous. Hopefully this video works. You're adding iron ore, you're passing electricity, and you'll see that orange portion start to grow. So as you add metal, you'll increase the volume of metal in the cell. That will reach a certain level, and then you will what they call tap metal. You'll drill into the cell, pour out some of that metal, plug that hole, and continue the process over. As that's happening, you're passing electricity through the cell the whole time. Again, there's no carbon in that cell. It's only electricity for energy to get everything to 1600 Celsius, 3000 Fahrenheit in the US, and emitting only oxygen as a byproduct. One of the key innovation, really materials side of things, is the anode technology. So it's an iron and chrome alloy with a few other elements added. It has to survive for years at 1600 Celsius in a molten electrolyte and being hit by oxygen. And that's a very, very challenging set of conditions. So that is really at the core of the IP behind Boston Metal, is how to design that alloy and ensure its life. It's much more fun to watch in real life, though. Sorry for this is pretty industrial audio if it plays through. You can watch the Paulus videos on our site, but that is, I know audio, that's good. So there's the show at the end. So 1600 Celsius, molten iron pouring out. I'll play it one more time just to show So again, they're drilling through refractory, and that's molten steel pouring out from the cell. The systems that we have online today, that'll make about 100 kilos of metal at a time, but it allows us to very quickly iterate on different process designs, different anode technologies, work with many different iron ores. I'll talk about that in a few slides. Where we're going from here is about a 10x jump. This will be the new system that's actually coming online this week. This will make tonnage levels of metal. Again, at a commercial facility in Greater Boston. So one wall away from where you're sitting in an office, you're pouring liquid steel. So it's quite a nice show. There's a glass window in the top left, stage right, where you can sit there and watch as metal's being poured. So a very, very, very different world, a very different setting than what you would see at a traditional steel mill. To do this, we'll talk about team, talk about partners. So we've got a team of 100 today. Most of them are scattered around the system. I think I was traveling that day, so I'm not in the picture. The team that designed and built that system that will bring that system online in the coming weeks. So engineers, electrochemists, operators, we're hiring like crazy. So if you're interested in making a change in an industry like steel, please reach out. You can find about a dozen postings on our website. And we also have a world-class team. So when I joined 5 years ago, it was a team of about 6. I joined right after our CEO. Today we're at 100, and it's really thanks to the partners that we've been able to raise to bring that team together. So the leading shareholder is the Bill Gates Fund, Breakthrough Energy Ventures. We've got a number of other financial partners on there from the venture capital world. Also partners like Fine Structure, which is the private arm of Fidelity, the large mutual fund. We have partners from the steel industry. BHP and Vale are the two of the largest iron ore companies in the world. BHP is the largest mining company in the world, working to ensure that their feedstock, iron ore, goes into a future production chain that's green. At the other end of the supply chain, you have an investor like BMW that represents the demand for green steel. And that's one advantage we have as a startup company and innovator. We don't have to prove demand. The automotive industry is screaming for it, the construction industry, and that's driving change all the way down the chain, through the steel makers, down to the automotive, down to the iron ore companies. We also have a number of investors from the energy sector. We can be as efficient as we want per ton, but if you multiply times 1 billion tons, you need tremendous amounts of electricity. It's taking about 15% of global coal demand and putting that onto the shoulders of the electricity sector. So we need strong support from the energy industry. We have traditional energy with oil and gas, climate initiative, 12 of the biggest oil majors. We have a number of electric utilities with energy impact partners. So the partners that will ensure that we have the clean power to scale this technology as we go forward. We will announce in the next couple of weeks our next round of funding. You'll see a major new partner that I think will send some shockwaves through the steel industry. But a couple of weeks to wait for that. Very similar plan to our last talker, so about the same timeline. We've scaled up the technology everywhere from lab scale reactors where you're operating in a coffee cup making grams of metal, but you can go really, really fast, to that largest system that will produce a few tons at a time in a batch. By 2025, we'll have our first commercial demonstration plant online that will make several thousand tons of steel per year, and then we'll license the technology in the later half of this decade for million-ton full commercial and industrial steel plants. As a business model, we also supply one of the core innovations, that anode. We will manufacture that, we'll lease that to customers. So that's our talk. The big impact we will have is that I talked about electricity and vehicle transportation, where the carbon age was 150 years and now it's ending. Boston Metal will help end the 3,000-year-old carbon age for steel. So thank you.